In which limits below can we use L'Hopital's rule? So L'Hopital's rule applies whenever you have a type of limit that results in an indeterminate form. Usually these indeterminate forms look like 0 over 0 or infinity over infinity. Not always, but generally. You have other types of indeterminate forms that could apply as well, but you rewrite those other indeterminate forms as these main two. So let's just check and see if any of these result in those. So the limit as x goes to pi over 5 of sine pi over 5 over, sine 5x over 5x minus pi. So let's see what happens. We'll call this a. So I'm going to come down here and do some work. So if I were to plug in pi over 5, I would be evaluating sine of 5 times pi over 5, and put that over 5 times pi over 5 minus pi. The 5's cancel, so I'm looking for the value of sine of pi, which you should know, but if you don't, know that your calculator does. But you have to know your calculator enough to be able to evaluate trig functions. The nice thing is this is a quadrantal angle, which you should at least remember that from trig. And quadrantal angles for sine and cosine always end up either being 0 or 1, so you don't have to worry about them lying in, root 3 over 2 or anything like that. Make sure you're in radian mode, because pi is a radian angle measure and not a degree. So anyway, sine of pi is 0, so you should be able to figure that out. 5 times pi over 5, the 5's cancel. Then you have pi minus pi, which is also 0. So that right there results in 0 over 0, so we could indeed use L'Hopital's rule to evaluate that one. It doesn't say to evaluate it, it just asks which ones work. All right, I'll call this b. We'll see what happens here. So when I plug in the limit value of 0, it's sine of 7 times 0 over 7 times 0. Well, 7 times 0 is just 0, and sine of 0 is 0. Again, you should know how to come up with that. 7 times 0 is 0, so this is an indeterminate form that we can apply L'Hopital's rule to. All right, moving down the line here, now we have the next one. The limit as x goes to infinity of the natural log of x over the square root of x. So what you have to consider when you're dealing with infinity is you can't plug that number in. The natural log of infinity is nothing. It doesn't make sense because infinity is not a number. What you need to think of instead is like what's happening with the graph of this thing. So when you have the natural log of x, you have an asymptote at 0, and it looks like this. It grows very slowly, but as x gets larger and larger, y values also get larger and larger. So the numerator here is infinity. So we have infinity, and you might be thinking, how in the world is that an acceptable argument of evaluating a function? Well, the reason that's an acceptable argument for evaluating the function is it's not a number, so you can't put the number in. You can't evaluate it in the first place. So the only thing you can do is look at the limit as x goes to infinity for that thing. And that's exactly what you're doing when you're looking at the graph, because ultimately limits result from what happens to the graph as you approach the limit value. So that yes, this is a perfectly valid argument. Same thing for square root of x. If you aren't sure what happens when you plug infinity into square root of x, well, just remember, here's the graph. As x gets larger and larger, the y values get larger and larger. So the denominator here also results in positive infinity. And that is a type of limit that you can apply L'Hopital's rule to. All right, lastly, that brings us over here to D. And we have the limit as x goes to infinity of e to the negative x over x. So again, this going to infinity, we can't just plug in infinity and get an answer. So we have to think about what would happen to the graph. So if I have y equals e to the negative x, and in the denominator, y equals x. All right, so in the denominator, we have just this line. As x gets larger, y gets larger, so that is clearly going to infinity. The numerator, I have e to the negative x. Well, e to the negative x, you might not know how this flip works, but you do have a calculator that can show you the graph. And what you should know at least is that exponential functions have an asymptote at 0, y equals 0 in particular. Now, I put it a little bit above the axis just so you can see it, but e to the negative x is going to look like this. What happens is the function gets closer and closer to 0 as x gets larger. So this is 0 over infinity. That's not a situation that you can apply L'Hopital's rule to. So the first three work, and the last one does not.